All right, kids, welcome to the first post-quiz video. We're going to do these just about every time this year when we have a quiz for you to learn the thing that happens right after the quiz on that day because we'll all finish the quiz at different times. This is the only information that happens after the quiz than before the test, so this is the only really difference between what's on the quiz and what's on the test is today's stuff. A lot of it's going to feel like review. We're doing 3-3 and 3-5 today. 3-3 is the coordinate stuff with slope, and 3-5 is just kind of the converse or backwards version of the fun rule things we did in class just before the quiz, the day before the quiz. All right, so slope. You should know a lot of stuff about slope from 8th grade. There's lots of times you have to graph lines and you have to know what the slope is to describe how the line exists on the coordinate plane. So just to review, slope is the amount of vertical change in a line divided by how much it changes horizontally in the same amount of space. We'll do some examples in a second to remind you how slope works. But why is this in the geometry book? Well, it's because they'll tell us about parallel and perpendicular if you look at the slopes of lines on the coordinate plane. So this is a little connection between geometry and algebra. Lines that have the same slope are parallel. So this looks like here, line L and line M, they both have a slope of 4. So we know they are pointing in the same direction. They both go up 4 for every one that they scoot left and right. It's always like over 1, 4 up, over 1. And they both do that, so they're both kind of pointing the same direction. They say non-vertical here because vertical lines are kind of special. They don't have slope. But of course, if you had 2 vertical lines, you'd know they're parallel also. They just don't fall under this theorem, technically. Same kind of disclaimer here with 3-3. They don't put vertical lines under this. But other than vertical lines, we can always find perpendicular by looking at the slopes. And if the slopes are negative reciprocals of each other, or if you could also say it this way, they multiply to make -1, then we know those are perpendicular lines. We'll get into why in a second, but first, some review on slope. First of all, slopes that kind of go uphill left to right, those are positive slopes. Slopes that go downhill left to right, those are negative slopes. Yeah, slope is just about direction. It has nothing to do with where these intercepts happen to be. It's just uphill, positive, downhill, negative, no hill, 0, and up against the wall, vertical, no slope. All right, let's find some. Oops, I had those. That was a mistake. Let's start this over. Okay, slope from A to B. So I should probably say something like the slope of AB. That is, I always start these the same way. It's the subtraction fraction. I put the y's upstairs and the x's downstairs. And I can start with here with a 5 or a -7. Doesn't really matter. But whatever I do up here, the 7, I have to agree with it down here when I go to do the x's. Biggest problem people make with these, and some of you were doing this on the pretest, was that you were usually upside down. You were doing the x's on top and the y's on the bottom. Let me just fill out the rest a little faster because you don't need to watch all the painful details of my handwriting. Okay, so this would be -2 and 5 on top, and then of course under the -2 has to, this is a negative. Under the -2 has to go 9, and then, oops, made a mistake there, fix that. Then what happens there if we get lines that have, or points that have the same x-coordinate, you realize we're gonna have 0 on the bottom, so this is no slope. There's no such thing. So we know another conclusion we can make there is that line's going to have to be vertical. Because you notice it's got 2 coordinates on here that have the same x-coordinate. Same x-coordinate are going to be lines that are above and below each other. That's a vertical line. We don't like that in terms of slope. And then for EF, put the y's on top and put the x's on the bottom. And I get slope of 2. Determine if any of the lines of these 3 are any of them parallel or perpendicular to each other. Okay, so we have a slope of -1/2, a slope of 2, and a slope of not at all. You would notice that the -1/2, if you multiplied that by 2, you'd get -1. So those slopes are perpendicular slopes. This is actually not a great way to write the notation, but I'm just showing it there so you can tell which ones I'm talking about. I do know that AB is perpendicular to EF. I'll put this in parentheses because that's really not officially how we should say that, but I'm highlighting that for you. Okay, fill in the coordinates so that this is supposed to happen. I think we're supposed to have this notation up here. Don't worry about that too much. All right, so the slope of CD is supposed to be -3. If these are supposed to be perpendicular, the slope of this would have to be the negative reciprocal of this slope, or it would have to be such that when I multiply those two slopes together, I'm going to get -1. So that's why the slope of that one is 1/3. Now I have to figure out how to fill in this coordinate so that the slope from here to here is 1/3. For now, let's just call this x, and let's solve for it. That 1/3 has to be the slope between these 2 points, and of course we know that's this difference on top over this difference on the bottom, and I can solve that for x. This equals 2 over 1 minus x. Looking at that first fraction, that second fraction being equal, kind of forget about this because I've simplified that. Let's cross multiply. 1 minus x equals 6, so x is 5. AB is supposed to be parallel. These are lines or segments or something. They're parallel with P and Q being where they are. Well, look at P to Q. Those have the same x coordinate, so these must be vertical. PQ must be vertical. So if this is supposed to be parallel, then AB better also be vertical. If it's vertical and B has a coordinate of 1, 7, A has a coordinate of something like 1, 5. Oh my gosh, they're the same line, aren't they, kids? PQ is a vertical line with an x coordinate of 1. AB has to be a vertical line with x coordinate of 1 because B is on there too. So it turns out AB and PQ are the same line. That's okay. They are still parallel because they have the same slope. They're going the same direction. Okay. This is going to feel like the lesson before the quiz where we talked about the two parallel lines and the transversal. This is kind of review. We've already talked about that. What's new this time, technically speaking, is the converse of that. And the converse means we're going to read this backwards and see if it makes any sense in terms of the if and the then. Here it was if two lines are parallel, then the corresponding angles are congruent. Here is if the corresponding angles are congruent, then the lines are parallel. What this is saying, by putting this in the book, they're saying, and calling this a new postulate, they're saying this is also true. And of course it's a postulate, so you can't really argue with them on that. But these are then the theorems that follow from that. And these are, you'll recognize them, they're exactly the same as the ones we saw 2 lessons ago. But again, they are kind of backwards from that. The conclusions are about parallel each time. If AIA angles are, here's AIA. If AIA angles are congruent, then the lines are parallel. If AEA angles are congruent, then the lines are parallel. If consecutive interior angles are supplementary, then the angles are parallel. On the theorem sheet, we don't make a difference between this version and the version we learned previously. We just call it a biconditional, which puts all that into one statement for each one of these, and you can just name that. You should be used to that by now already because you had to use that on the quiz. Okay, determine what 2 lines are parallel given this information. So we didn't do problems like this before the quiz. This is a little bit new. These were all the pre-tests, and people did have a problem with this a bit, actually. If 1's congruent to 4, okay, 1's over here, 4's over here, 1 and 4 are, if you'll notice, you look carefully, what's hard about this is there's so much extra junk in the picture. 1 and 4 are corresponding angles here and here. They're corresponding, think about where the transversal is that connects 1 and 4. It's this transversal. So the 2 parallel lines we must be talking about are these two, L and M. So the conclusion here is that L is parallel to M. The reason for that was, well, we actually noticed that first. It was because they were corresponding angles. I'm going to erase that before I do the next one so it doesn't bug you. All right, so the next one is 4 is congruent to 6. So think about the sides of 4, think about the sides of 6. It kind of looks like, okay, there's the sides of 6, here's the sides of 4. All right, 6 and 4 are at these 2 intersections, and they share this kind of common side. So this is the transversal. These would be the parallels. J and K would be the parallels. Here, those lines, if you look at those 2 lines and the way these 2 angles are sitting on them, they are alternate interior. And then the last one, just a second, let me erase again. Okay, so if 2 plus 3, which is, you can actually mark that really nicely there. 2 plus 3 is the same as 5. It looks like we have corresponding again, but this time the corresponding, all right, so these are the 2 intersections right there. That connection of the intersections, that's the transversal, so the lines parallel must be L and M. I think the hardest part about this is determining which lines we're talking about. So go back and watch that if that was difficult. Okay, oh, actually we have some more here on the top of the next page. If 6 is congruent to 8, those are corresponding. Their connection is this line J, so that's the transversal, and the lines that make up the other sides of those angles are L and M. 2 plus 3 plus 8 is 180. All right, 2 plus 3 and 8, if we added all that up, they're not congruent, so I'll do it that way. 2 plus 3 plus 8 is all 180. You probably thought you saw this coming, that we've got these inside angles here that all add up to 180. They're supplementary, so that means this is a consecutive interior situation, or an SSI. So here's the letter U from the fun rule stuff. J is parallel to K, and that's CIA. Okay, next rule, 7 and 1. 7 and 1, 9 and 10. 9 and 10, 9's up here, 10's down here. Those are exterior. They are on alternate sides of this transversal if we look at the connection between the intersections they're on. So yeah, this is AEA, that's perfectly legal. AEA, and if that's the transversal, the other sides of those angles, 9 and 10, are K and J again. So J's parallel to K. 1 and 7. 1 and 7 are simply vertical angles. The sides of their angles only touch two different lines. So there's really no conclusion you can make here. There's no parallels. If that's all you knew, there's no parallel conclusion. 4 and 5, again, those are linear pair angles. If they're equal, well, I guess that tells me that these are both 90 degrees because they make up 180. And if these are equal, then okay, that would mean these lines must be perpendicular. So I guess the best conclusion I can make here is M is perpendicular to K. That's kind of fun. Why is that? Oh, I'd say linear pair. If linear pair angles are equal, that implies that they must be 90. There's a little bit of algebra implied in there. That's kind of a strange rule. I don't think we have that as a theorem yet, but that would be true. 5 and 9 make 180. Same thing. I don't really know. 5 and 9, I don't have a name for that. I do know that they're supplementary, though, because think about this. 4 and 9 have to be corresponding, so they're congruent. So this is really the same statement as, this is equivalent to this, so I could kind of say all the same things for that one. It's kind of a stretch, but that does work. And 8 and 4 congruent. Those are on opposite sides of this quadrilateral. The sides touching 8 are these two lines. The sides touching 4 are these two lines. There's no one connection to use as a transversal. So actually, there's no conclusion that can be drawn from that either. All right. Okay, find the values of x and y that make these parallel and these parallel. All right, so if everything's going to be parallel, I could say things like these have to be corresponding, and so that'd be congruent. These are same side interior, so let's set that up. Okay, there's the setup. Let's simplify both of the equations as much as we can. I get that part far pretty quickly, and actually this second equation, everything in here could be divided by 2. That kind of helps a bit. Oh, because look at this. Now I have 5x and 5x. So now I can subtract these two, and life is going to be easy. Negative 50 equals negative 12y minus negative 2y is going to be negative 10y. So I know y is 5. Okay, and if y is 5, I think the best thing I can do is substitute back into this equation up here and say 30 equals 5x minus 60. So 5x is 90. And x is 18, I think. Okay, so find the values of x and y. I have done that. Oh, can I get done in under 15 minutes? All right. Okay, this is just some parallel and perpendicular versions of the stuff we've already seen. It's like special case. Like if you have perpendicular here to the two, if the transversal is perpendicular, you can kind of mush together some of these AIA and corresponding rules and get some slick ones that happen quite a bit, actually. One of them is this one. In a plane, if two lines are perpendicular to the same line, then they're parallel to each other. That's a special case of the converse postulate. And this other one is actually more like one of the Euclidean original ones. And we talked about this in class. If you have a line and a point not on the line, then there's only one line through that point that's parallel to the first line. Kind of a philosophical thing there. All right, here are some proofs. Let's think about this. Okay, some of this is filled out for us, so some of this is super easy. Let me start. First of all, you have to put given there. The only thing that are possibly vertical angles are the angle 2 is congruent to angle 5, so let's mark those. Then I want to figure out something by transitive. Okay, look at what I have here. I have 1's congruent to 2, 4 is congruent to 5. Oh, look, I have a link here. 2 is congruent to 5. So the transitive conclusion here is that 1 is congruent to 4. Marking that in the diagram, I notice that that makes AIA angles on the lines I need to be parallel. So this is AIA. All right, I got 20 seconds. Okay, so I copy the problem, look at the picture, and see what's obviously true after that. Looking in the picture, I find instance of the perpendicular transversal converse. And since they're parallel, I get AIA. The angle bisector gives me 2 and 3 congruent. Now I have a transitive string to make the proof finished. Goodbye.